Hi, I'm Adam. In this challenge, I'm going to show you how to solve a coding challenge regarding pangrams. So we've got this challenge here. It's where we've got a function called isPangram, and isPangram takes a parameter string. And we need to determine whether string is or is not a pangram. And a pangram is a sentence that contains every single letter of the alphabet at least once. So that is the gist of it. And that's generally what we're trying to do. But there's a couple of things we've got to consider. So, for example, the sentence, the quick brown fox jumps over the lazy dog, is a pangram because it uses the letters A to Z at least once. Case is irrelevant, so that's one of the edge cases we need to consider. So we just need to go and determine whether string is a pangram, and it doesn't matter whether the letters are uppercase or lowercase. If they occur, they should count as an occurrence of a letter of the alphabet. So there's probably quicker ways to do this, but I'm going to expand this over a few lines. And I'll start by writing a comment, which is store in alpha our alphabet. And we'll store in a string A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Just have a quick check. Yep, that looks fine. So I'm storing my alphabet there. And then we're going to store in, we'll say within, in alpha, an array of chars in string that are in alpha. So we're going to store in this next variable, in alpha, an empty array initially. But what we'll do is we'll iterate over this string, and for every character in the string, including spaces, uppercase and lowercase letters, and punctuation or whatever's in the string, we're going to iterate over it. And if it's in alpha, we're going to store a copy of that. We're going to push it to in alpha. So now I can do my iteration, iterate over string, and for each char that is a member of alpha, store it within in alpha. Great, so we're going to go and do that now. String. And what we need to do first is another method. We're going to lowercase it all first. So I could just return that for now and just check. That has now taken, so that one capital letter there, the T, is now a lowercase t. And that's what I want because we're comparing everything in here with everything in here. So we're comparing everything in this string with everything in this string. They both need to be lowercase to match and to be checked as members of alpha. So now I'm going to split it into an array of characters. So there we go. We've got all of the characters, and now we kind of want to cleanse it a little bit by iterating over it with for each. We throw in a callback function, and I'm going to spread this over onto a few lines. And now I'm going to check if char is in alpha, push to in alpha. So if alpha includes char, so that will return a Boolean if it's true. So this kind of expression here, if that evaluates to true, then this part will run. And that's where we go in alpha push char. I'll get rid of that return and bring this back down here. Now I want to return in alpha. And we'll just check what in alpha looks like. So in alpha now contains all of these characters in this string that are members of this lowercase. So this is all lowercase. All of these members of the string that are within alpha are now in alpha. So I hope that makes sense. We can see they're there. But we've got one little thing to consider, which is this edge case. So, well, not really an edge case as such. It's how do we determine now that we have a pangram? So what am I going to use to quantify whether we've got a pangram? we've got a list of all of the characters that are in the alphabet within this string, and that's what we've achieved with this set of code here. What we need to do next is then compare it, I guess, with the length of the alphabet. Because if we have exactly 26 letters in alpha, then we've got a pangram. But we won't because of this consideration here. Well, we've got duplicates. O appears twice, for example, in dog and over. So we've got it there, O, and then we've got it here as part of over. So what I need to do is get rid of duplicates. And to do that, I'm going to first, we'll get rid of the length part first. And we're going to do a cheeky little trick here. We're going to convert it into a set, basically. And a set in discrete mathematics is a collection of unique items. So we're going to do that. I'm going to use this spread syntax, and we'll go new set. And we're going to turn this array into a new set. So it's still false. We'll get rid of this part here. That's because I'm not actually I'm not comparing it to a number. Now, if I check THEQICK, so it should actually read exactly that sentence, but without any duplicates. So the quick, there we go, the quick brown fox, and we've already used an O, so that there's no O there. FX jumps, so we've already used a U, that's up there. MP, S, over, OV, we've already used. So everything that's a duplicate is gone now. And we're left with unique values that were in alpha. So I could right here compare a set, compare unique, the number of unique values in alpha with the length of the alphabet. So now if I do length, I'm going to get 26 if this is a pangram, and I do. So all I need to do to finish this off is just check, is that equal to 26? And it's true. So that's it. I first declared what the alphabet was. I then created an array called inAlpha, or I stored within a variable called inAlpha an empty array. I iterated over string lowercase, split it first before doing that into an array of characters. And for each character, if that character was included in alpha, I pushed to inAlpha the character. Then I had a collection of all the characters that are in the alphabet within string, stored within alpha. And what I did was I converted that array into a set, and it also was instantiated as an array within that using the spread syntax. And I got the length of that, and that was 26. So that gave me all the unique characters in alpha, which are members of alpha. And I just compared that to the number 26, which is how many letters we have in the alphabet. So that is generally how I solved that challenge. Not too tricky, but I used some little tricks here and there. So hope you enjoyed that. Thank you very much.